Greetings, one and all, and welcome to this math lesson. It's interesting. The previous one that I had up, the previous one that I did before this, they said that nothing was showing, and hopefully something is showing now. Okay, so we're gonna start over. And so the topic for this lesson is applying the division algorithm. Applying the division algorithm. And this question, so let's consider this question. And the question is, let me write it again. And the question is the following. So the question states what? Use, right? Use the division algorithm. Use the division algorithm. All right? Use the division algorithm. It's supposed to be HM. Use the division algorithm to establish that what? To establish that A, this is actually the part A of the question, that the square of any integer, is either of the form three k or 3k plus 1. Okay, so the question wants us to use the division algorithm to establish that the square of any integer is either of the form 3k or 3k plus 1. And this question is coming from our first homework number 1, from the course Math 350. And this is a course that I'm taking now, and it is number theory. And so they want us to use the division algorithm to prove this statement. But what this statement is saying, though? What's the claim of this statement? Like, what does it actually mean? The square of any integer is either of the form 3k or 3k plus 1, right? First, let's talk about what is an integer, all right? What is an integer, right? Well, integers are numbers that are part of this sequence. So we have -3, -2, -1, 0, 1, 2, 3, and so on, right? Integers are any numbers that are part of this sequence of numbers, right? So integers are positive numbers, right? And they are negative counterparts, and also 0. Okay, that's what integers are. And so what this question is saying, or what the claim of this statement is that give me any integer. So any one of these, 1, 2, 3, 4, -1, any integer you could think about in the world. And then I want you, once you're ready, give me that integer. I want you to square that integer, right? Raise it to the power of 2. And once you square that integer, I can guarantee you that that integer is either going to look like this, 3k, or it's going to look like this, 3k plus 1. That is, it's either going to be a multiple of 3, or it's going to be a multiple of 3 plus 1, right? And that's a strong claim. It's a good claim, right? And so let's expand it a little more. Let's map it out a little bit more with an example. So give me an integer, any integer in the world, any one, and we're going to apply that to it. So let's say we used integer. We could use any integer, but let's say we used integer. Let's say we use 5, right? So you have this integer 5, and then they say square the integer. All right, so we're going to square 5. And what is the square of 5? That's indeed 25. All right. And they're saying that the square of that integer, which is 25, is either going to be divisible by 3, or it's going to be a multiple of 3 plus 1. Now, indeed, 25 is not divisible by 3, but what can we, like, how can we write this? How can we write 25? Well, we can write 25 as 24 plus 1, right? And we can write 24 as 3 times what? 3 times 8. And so there you have it. Notice, right? Notice that 5 squared, right, is equal to what? 3 times an integer plus 1. So that's exactly that. You see what I'm saying? All right, let's try another integer. So let's use say 3. All right, so let's use an integer. Let's use 3. And let's see what 3 gives us. So if we use 3, what will happen? We'll have 3 squared. And what is 3 squared? 3 squared is indeed what? 9. But what is 9? Can we write 9 as 3 times 3? And isn't this the same thing as 3k, where what? Where k equals 3? So you see, we got this one. So that's what the claim is. The claim is, give me any integer, right? And square that integer, and I could guarantee you it's going to be either a multiple of 3, or it's going to be a multiple of 3 plus 1. All right, and that's the claim. And we ought to prove this claim. All right, so let's prove it. So, and again, if you have any math question, pertaining to any class, please feel free to put it in the comment section below, and we'll see if we can consider those questions. So let's begin with the proof. So we want to prove this. So proof. So we start off generally. So we say, okay, give me any integer, right? And call it h. So let h be an integer. So let h be an integer. So give me any integer, and let h be that integer, right? So really, I should say like this, let h be any arbitrary integer, right? So h is an integer, and h is going to have the character, being an integer, h is going to have the characteristics of an integer, all right? So let h be an integer. And what do we know about any integer? There's a lot of things we know about integers, right? But specifically, what do we know about integers that would help us with this problem, right? Okay, let's consider the sequence. So we have 3, right? We have 3, then we have 4, then we have 5, and then we have 6, right? Notice, right, that we have 3. Now, when I divide 3 by 3, right, what's the remainder? The remainder is 0. Now, when I divide 4 by 3, what's the remainder? The remainder is 1. And when I divide 3 by 5 by 3, what's the remainder? The remainder is 2. And notice, right? And let's continue the cycle. So we have 3, 4, 5, 6. I'm going to do 7, 8, and 9. And then when I divide 3 by 6 by 3, the remainder is 0. And then when I divide 7 by 3, the remainder is 1. And then when I divide 8 by 3, the remainder is 2. And then when I divide 9 by 3, the remainder is 0. Don't you see a pattern? Notice, right? Notice that we have what? We have 0, 1, 2. And then the cycle continues. 0, 1, 2. And the cycle continues. 0, 1, 2. So what does that mean? What does that tell us? That tells us that any integer, right? Any integer that you can think of, either when divided by 3, is either going to have a remainder of 0, it's either going to have a remainder of 1, or it's either going to have a remainder of 2. You cannot divide a number by 3 and get a remainder of 3, right? That's impossible, right? So that's something that we know about integers. Integers, any integers you could think of, either has a remainder of 0 when it's divided by 3, a remainder of 1 when it's divided by 3, remainder of 2 and it's divided by 3. Now, if it have a remainder of 0, then that means it's a multiple of 3. So that means we have 3 times 1. And if it has a remainder of 1, then that means that it is not quite a multiple of 3, but it's a multiple of 3 plus 1. So we have 4, right? So 4 can be written as 3 times 1 plus 1. See that? And then if it has a remainder of 2, then it can be written as what? 3 times an integer, which is, we could use, say, 3 times 1 plus 2. Okay? So, hopefully what you can get from this example is that any integer that you give me is either a multiple of 3, or it's a multiple of 3 plus 1, or it's a multiple of 3 plus 2, right? And we could do the same thing for 6, 7, 8, and so on. But any integer you give me, it's either going to be a multiple of 6, a multiple of 3, any integer you give me, it's either going to be a multiple of 3, a multiple of 3 plus 1, or a multiple of 3 plus 2. And we're going to use that idea in answering this question, all right? Okay, so let's use that idea. So remember we said that h is any integer. H is an arbitrary integer. So you can think of it as you have a bag full of integers, and you close your eyes and you pull out any integer from there. What can you expect? What could you say about that integer? Remember, your eyes are closed. You're just putting your hand inside that bag and you're just pulling out an integer. What could you say about that integer, h, right? Well, what you could say is that, I mean, you don't know exactly what it is, but what you could say is that, well, h, I don't know exactly what it is, but I know that h either is a multiple of 3, or h is a multiple of 3 plus 1, or h is a multiple of 3 plus 2. And believe it or not, by doing that, that is the application of the division algorithm in this problem. So we say then by the division algorithm, because it's the division algorithm that is the reason why we're able to do this, right? That gives us the mathematical backing to do this. Even though I explain it intuitively, I use the division algorithm in my explanation, because the division algorithm is the one that helps us when we are dividing integers, when we're dividing numbers. So we say then by the division algorithm, or if you don't want to say by the division algorithm, you can say then by common sense, right? And don't put that in your working, but to be honest, that's what it is, right? Because I didn't use the word division algorithm in any of my explanation and explaining to you it. I just use the common sense way of explaining it. In math, we call it the division algorithm, but really, it's common sense. And to be honest, a lot of the science is just a systematic application of what we know by common sense, right? Anyway, so let's do this. So what do we have so far? Let h be any integer. So I'm taking any integer, I'm going inside the bag, closing my eyes, getting a random integer. And what do I know about this integer? This integer is either going to be a multiple of 3, it's either going to be a multiple of 3 plus 1, or it's going to be a multiple of 3 plus 2. Okay, so let's move on. What else can we say about this? Right, what else can we say about this? Okay, what else can we say? All right, so we don't know what it's going to be, right? When we put our hand inside that bag and pull out an integer, we don't know. We know it's an integer, but we don't know which one of these specifically it's going to be. And because we're providing a proof, we have to consider all cases. So suppose it is a number, like suppose we got something like 9, that's a multiple of 3. Or suppose we get something like suppose we got something like 4. Suppose we got something like 5, right? then we have to account for each of those cases. And so therefore, we would say, let's start off with the first case. Suppose, and I should mention that q here is an integer, right? So for q, an element of z, that means that q is an integer. All right, so now suppose, right? Suppose we're going to start with our first case. Suppose h equals to 3k, to 3q. That is, suppose we got an integer that is a multiple of 3, right? All right, so let us now, remember what we have to do. We have to prove that this integer, when we square it, it's either going to be of the form what? 3k or 3k plus 1. So let us do this. So suppose h is equal to 3k. Then, or we say this implies that what? Let's square both sides. If we square both sides of the equation, what do we get? We get 3q squared, all right? And this implies that what? That we have what? In fact, let's do it on this side. So what is 3q squared? That'll be what? 3 squared q squared. And that'll be what? We could actually pull out the 3. So we'll have what? 3, open bracket, 3q squared. Does that make sense? Notice that what? Notice that we can multiply the 3 by the 3 to get 9. And notice that we can, and if we get 9, that's exactly what 3 squared is. All right, so I just wrote it a different way. And I wrote it specifically like this so that it could look like the form that we are trying to achieve. So therefore, what? Therefore, h squared is going to be equal to what? 3 times what? Times k, where what? Where k equals 3q squared. Now, 3 is an integer, q squared is an integer. Because if you square integer, you get an integer. And 3, of course, is an integer. So therefore, and when you multiply integers, you get an integer. So therefore, 3q squared is definitely an integer. So we have it. We have it that what? That h squared is equal to what? 3k. And that was what we try and achieve. We say that when I square this integer, right? When I square it, I either want it to be of the form 3k or I want it to be of the form 3k plus 1. Here we got it of the form 3k, and that's good. Once we get one of them. Okay, so for this one, good. So if you go on your bike and you miss and get a integer that is a multiple of 3, you know that for sure, yes. When I square it, I'm going to get something of the form 3k or 3k plus 1. All right, let's consider the second case, 3q plus 1. All right, so now suppose that what? Suppose that h equals 3q plus 1. All right? Suppose that h equals 3q plus 1. So suppose when you go in that bike and you pull out that h, that random integer h, suppose that you got a number that is not a multiple of 3, but it's a multiple of 3 plus 1. So that is like, say, a number like 4, right? Or a number like, I'm thinking like a number of, I think 7 would also be something like that, because if you look at 7 would be what? 3 times 2? Yeah, 3 times 2 plus 1. So suppose you get a number like 4 or a number like 7, right? Wherein it's a multiple of 3 plus 1, right? Does that also work? All right? And we have to prove that. So let's square both sides. So if we square both sides, we have what? H squared. So that'll be what? 3q plus 1 all squared. And this implies that what we have? H squared is going to be what? 3q plus 1 times what? 3q plus 1, because it's squared. And then now we're going to what? We're going to multiply. So 3q times 3q equals what? 3 times 3 is 9. And q times q is q squared. And then we have what? 3 times 1. 3q times 1. What is 3q times 1? 3q times 1 is indeed what? 3q. Alright, so that's good. Now we say what is 1 times 3q? Well, 1 times 3q is 3q. And what is 1 times 1? Indeed, 1 times 1 is 1. And so that's what h squared is. H squared is this entire expression. Alright, so let's continue to simplify. So now we have h squared equals to, we can write this as what? 9q, sorry, we can write this as 9q squared. 9q squared. Now 3q plus 3q is what? Indeed 6q. Right, so we have 6q plus 1. And let's factor out a 3. So see if we can factor out a 3. So if we factor out a 3, that'll be what? 3 open bracket. 3 times 3 is indeed 9q squared plus 3 times 2 is going to give me the 6 that I need, q plus 1. You see, Isaac, what did you do? Notice, right, that if I have 3 times 3, that's going to give me the 9 that I need up front. And if I have 3 times 2, that's going to give me the 6 that I need here. So therefore, this is saying the same thing as this. Okay, so what do we have? We have that what? Let's finish this off. We have that h squared is equal to 3k plus 1, where what? Where k equals 3q squared plus 2q, and that is indeed an integer. Why it's an integer? Because, let me explain to you why it's an integer. 3 is an integer, so that's good. Q is an integer, and if you square an integer, it's still an integer. If you multiply 3, so that means 3 and q squared are integers. Good. But if you multiply integers, you still get an integer. So that means 3q squared is an integer. Now, we have 2. 2 is an integer. And q is an integer. And when you multiply integers, you still get an integer. So this is an integer and this is an integer. And when you add integers, it's still an integer. So this whole thing must be an integer. So we have that h squared equals to what? 3k plus 1. And that's what we wanted. We wanted it to either be what? 3k or 3k plus 1. And in this case, we got it. In this case, we got it. Awesome. So if your h that you chose from that bag was a multiple of 3 plus 1, then it would also work. All right. Okay, so let us now consider the last case. And the last case is if we suppose that what? Suppose that h is a multiple of 3 plus 2. Alright, so suppose that h is a multiple of 3 plus 2. And we need to prove that that when we square h, it's either a multiple of 3 or a multiple of 3 plus 1. So let's see. So let us square both sides. So that means we have h squared, and then we have what? 3q plus 2 all squared. And this will be equal to, if we say this implies that what? h squared is going to be equal to 3q plus 2, open bracket, 3q plus 2. Good. Now let's multiply. So we have 3q times 3q. 3q times 3q is what? 9q squared. We saw that already. And 3q times 2 is what? 3 times 2? 3 times 2 is 6. So we have what? Plus 6q. Okay, good. Now let's consider 2 times 3q. Well, 2 times 3 is 6. So we have 6q. And 2 times 2 is what? It's indeed 4. And so we have that what? h squared equals what? 9q squared plus 6q plus 4. Let's simplify some more. So we have h squared equals 9q squared plus, let's look at this as 12, because 6q plus 6q is 12q. And what is 4, right? What is 4? What can we write 4 as? We can write 4, can we not write 4 as can we not write 4 as negative 6 plus 2, right? Isn't 4 negative 6 plus 2? Yes, because think of it. If you owe someone $6, right, and you have $2, and you pay them the $2 that you have, how much do you still owe them? Think about it now. You owe them 6, and you have $2, and you pay them the 2 that you owe them. Sorry, you pay them the 2 that you have. How much do you still owe them? You owe them 4, right? So therefore, negative 6 plus 2 is indeed what? Negative 4. Good. So therefore we have that this expression here is equal to that. All right. And I did that because it's going to help me when it's time for me to factor things out. All right. So let's go. So we have, this implies that what? 8 squared equals what? We're going to factor out the 3. It's going to be what? 3q squared plus 3 times 4q minus what? 3 times 2 is 6 plus 2. You say, Isaac, what did you do there? Right? Notice that 3 times 3 is 9. So that's the 9k squared. I notice that 3 times 4 is 12. And that's the 12q right there. I notice that 3 times negative 2 is what? Negative 6. All right? And we did not factor any 3 here. We just bring down the plus 2. All right, so this implies that what? 8 squared is going to be equal to what? 3k plus 2, where what? Where k is equal to what? 3q squared plus 4q minus 2. And that is also an integer. And it's an integer because of closure properties. This is an integer, this is an integer, this is an integer. And when you add or subtract integers, they still get an integer. And there we have it. Look at that. Look at that. 8 squared is equal to what? 3k. That's interesting. Why we have 3k plus 2? We wanted it to be, and that's interesting. That's interesting because that's very interesting. We don't want it to be, we want it either to be the form 3k plus 1 or 3k. No, this is not right, because if we have it, and it's a good thing that I'm looking over this, because now I realize there's something wrong. If we have, and we have to correct it, if we have, yeah, that's something wrong, because we need it to be either of the form 3k or 3k plus 1. Okay, so where do we need some assistance here? Okay, can't be 3k plus 2. Okay, so we have to change this. It starts from right here, from the same negative 4. Sorry, from the same 4 right here. So let's do this. What is 4? And so let me just be honest. I did not foresee this mistake, and to be honest, I already wrote the answers to my homework, and I have this mistake in it, and it's a good thing that I'm doing it here, and I see the mistake. So let us correct it. All right. So this is an experiment for both me and you. Let us correct it. What is 4? All right. 4. We need to write 4 such that, because the problem is we cannot pull out a 3 from 4, right? That you cannot do that unless you express 4 as a sum. So what we're going to do is we're going to say what is 4 exactly, and we're going to try to do it such that we get 1 at the bottom. I mean, we get 1 diagonal along. What I mean is we want something of the form 3k plus 1, right? So we need to have 4 written such that there's a 1 such that in its sum there's a 1 hanging out there, and it have to be a plus 1, right? So what can I add to 1 to give me 4? And so let's consider that. So in fact, let me go to the next slide. So what can I add to 1 to give me 4? All right, so wow, it's a good thing to do these questions online, because then I get to see my mistakes, and you all get to see also that that it's a process, right? That sometimes um, we even as math majors make some errors, but we gotta learn how to what work through those errors. So I like this. I like that there was a mistake that I didn't see in this question, that in my solution I should say. Okay, so let's send this over. So it's gonna be what, x equals to 4, and since this is a positive, when we send it over, it's gonna be a negative. So it's -1. So x is going to be equal to what? X is going to be equal to 3. But yeah, that makes sense. 3. So 3 plus 1. Wow. That makes sense. And we can clearly see that 3 plus 1 equals 4. Good. All right, so wow, all we needed to do was, instead of putting it as -6 plus 4, all we needed to do was express it as 3 plus 1. That's interesting, right? Why did I go to the whole mess of using that -6 plus 1, right? Yeah, sometimes we get beside ourselves. So good. So now we just need to put it as what? 12q plus what? Plus 3 plus 1. Awesome. And now, since we have that, and that's 4. We can clearly see that's 4. Okay, now what do we have now? So this is going to be plus 1, and it's going to be plus 1. You see, Isaac, what do you mean? I'm going to show you right now. 3 times 3 is 9. That's the 9 and q squared right there. 3 times 4 is 12. So that's 3 times 4q, which is what? 12q. 3 times 1 is what? 3. You see that, right? So we have all of this. This whole expression here is this exact thing. And then we just plus 1. So we just bring the plus 1 down. Plus 1 and plus 1. Awesome. Wow, what a correction. So I need to correct that on my solution. Interesting, right? So we have 8 squared. So 8 squared is going to be equal to what? 3k, right? 3k plus 1, right? Where what? Where k is going to be equal to 3q squared plus 4q plus 1. And of course, that is indeed an integer. Why is it an integer? It's an integer because 3q squared is an integer, 4q is an integer, and 1 is an integer. And when you add integers, you also get an integer. Awesome. So now we have that what? Now we have the right thing. That 8 squared is equal to what? It's equal to a multiple of 3 plus 1. All right? So we considered all cases, right? So we considered all cases. So how are we going to conclude? Therefore, right? That's how we're going to conclude. Therefore, so we know that in all cases, we either got what? 3k or 3k plus 1. So therefore, we can say, right, that what? That the square of any integer, is either of the form three k or 3k plus 1. All right. And we're done. That's the proof. Awesome. All right, so let's go into the comment section and see if anyone post a question. Let's see if we have something there. Okay. Okay, this. Okay, oh, this. LOL was thinking something. Look oddly familiar. Okay. All right. Okay, I don't see any questions. So again, if you have any questions and you would want um and you would want if you have any questions and you would want me to from any course, any math course, and you would want me to consider them, please put them in the comment section or put them inside the UB Survival Guide somewhere, and we would seek to provide a response um, to those questions. Now, if you would like tutoring, let me just put, if you would like tutoring for math, right? Whether it be, or if you know someone who needs tutoring for math, it does not even have to be college math, but math of different levels, right? Primary school, high school, whatever. Then don't hesitate to message me here on Facebook or contact me at 428-8971. And if it's international, of course, the area code is 1242. But the area code is really 242. I don't know why some persons also put the 1, but I guess that's a part of it some way, somehow. But that's it there. That's my number. And or you could also use the Facebook messaging. All right, thank you so much for your time and for your attention, and I'll see you in the next video.